in addition to the monatomic ions we talked about in the last video, there are additionally ions that can be formed from multiple atoms that combine to form together an ion. This is sort of a combination of a molecular compound, but it's charged. So it forms covalent bonds between the atoms, but the whole thing is charged. So let's look at some examples of this. Maybe that'll help make it clear. And then we'll look at a list of common polyatomic ions that I want you to become familiar with the names that we give them, because they show up a lot in chemistry and in your labs. So let's look at one example, which is this ion here, CO3 2-. This is the carbonate ion. So this behaves together as a molecule does. So it has a carbon, and it has 3 oxygens bonded to it. And overall, this carries a 2- charge. And so this is a sort of a combination of the molecular and ionic ideas. But you can combine, say, carbonate with like a monatomic ion. So something like, say, sodium, Na+. Sodium's one of those elements where the symbol for it, Na, comes from Latin, and so it doesn't match our English name for the element. But we're sort of stuck with it because of historical reasons. Anyway, we can combine this monatomic Na+ with this polyatomic carbonate to form a compound. And so one thing I forgot to mention in previous videos is that when we're forming ionic compounds, we always need to make sure they are electrically neutral. What do we mean by that? It just means that all the positive and negative charges need to cancel out. We can't have a compound sitting around that just has extra positive or negative charges, right? Everything needs to balance out, or else it wouldn't be a stable compound. And so because sodium only has a 1+, we'll need 2 of these to balance out the -2 charge that's on the carbonate. So we can combine these two, Na2CO3. So this tells us that we have 2 Na+, or 2 positive charges, and that goes with our 1 carbonate, CO3 2-, and the charges balance out. And so we can form an ionic compound here, sodium carbonate, that's composed of both a monatomic ion, the sodium ion, as well as a polyatomic ion, the carbonate. Now, there's no rules about us needing to do monatomic and polyatomic separately or whatever, so we could have 2 polyatomic ions combined. There's just not very many of them that are positively charged. Almost all positive ions are metals, and the one exception that I'll just mention right now is the ammonium ion, NH4+. Or I should say the one common exception. And so we can combine ammonium and carbonate. So ammonium carbonate is a perfectly normal molecule. We would need 2 of the ammoniums, just like we needed 2 of the sodiums, and we can combine that with 1 carbonate. And again, this is a formula unit, right? This will form a crystal just like the sodium chloride that we talked about. This is an ionic compound, but the individual atoms are covalently bonded together, right? The individual ions have covalent bonds between the carbon and oxygen, and here the nitrogen and hydrogen in the ammonium. Now let me switch over to my other screen here. And so this is a list of ions to sort of summarize this. Common ions that I want you to work on memorizing if you're not already familiar with them. So this is a PDF that is posted on Moodle, and I want you to start working on memorizing these. So we have common cations. There's 2 pages. So we have the +1 charges listed here. Now most of these are monatomic, and if you are familiar with the trends that we talked about in the last video, you can see a lot of these you can just know from the periodic table, but we do have a couple of extra ones, the silver and copper 1 ion. Copper is one of those ones that can be 2 different charges, so you have to specify. And we have the names here. We'll talk more about naming in just a little bit. Then we have a list of +2 charges. Again, a lot of these come from they're that second column of the periodic table, but there's extra ones that are from the transition metals particularly. And then a few of the +3 charges. And then the anions are on the second page, -1 charges. With the anions, we have, of course, all of the, so here's one example of an exception. Hydrogen can either be +1 or -1. So hydride is an ion that shows up. But a lot of these are halogens, and then we get a bunch of polyatomic ions. Things like, and these sort of all get their own names that it's part of like learning a language. You need to become familiar with these things like acetate, nitrite, nitrate. We'll get into some of these naming a little bit. 2 minus charges, we have a bunch here, 3 minus charges. And then at the bottom, there's a list of common strong acids. We'll talk about that in a little bit. But this is something that I want you to work on becoming familiar with. Just keep working at it. You can make flashcards is a good strategy to go with here. So, and this will be useful in knowing when you look at a chemical formula, understanding what you're looking at.